X-rays have high energy and high frequency with wavelength in the range of 0.01 to 10 nanometer. X-rays are produced by energy conversion when a fast-moving stream of electrons is suddenly decelerated in the target anode of an X-ray tube. X-ray tube is a device used to produce X-ray beams. It is a diode containing anode and cathode enclosed within a Pyrex glass in a vacuum chamber. The two electrodes are connected across high electric field, which accelerates electron produced at cathode towards anode. Here is a simplified diagram showing different parts of our X-ray tube. We will now study each part in brief. Cathode is the negative electrode as electrons are produced here. They are made up of metal like tungsten, which have a high melting point. When high-volt electric current passes through a cathode, electrons are released from outer shell of cathode metal. As we use electricity and in return releases electron, this process is known as thermionic emission. High-voltage electric supply is connected between cathode and anode. This helps in production of electrons as well as accelerating them towards the anode. Anode is positive electrode of X-ray tube. Here, accelerated electrons with kinetic energy strike off and lose all their energy. This energy loss is converted mainly into heat and rest 1 to 2% converted into X-ray beam. Both cathode and anode are usually made up of tungsten. Tungsten is used because it has a high melting point. One exception to this is molybdenum anode, which is used in mammography. These anode produce more characteristic spectrum of X-rays, which is discussed later on in this video. Vacuum chamber is applied to decrease resistance in the pathway of accelerated electrons. As air contains many other elements like nitrogen, oxygen, carbon dioxide, these atoms will hinder the path of moving electrons. Oil bath is used to absorb heat produced while creating X-ray. A lead chamber is created to prevent unwanted spread of X-ray in all direction. Few other parts are described below. Now we will discuss the spectrums related to X-ray production. They are continuous spectrum and characteristic spectrum. Continuous spectrum is known as Bremsstrahlung spectrum. It consists of 70 to 80% of X-rays produced, hence more common spectrum of X-ray production. It is produced due to loss of kinetic energy of electron on striking anode. As different electrons travel at different velocities, loss of kinetic energy is variable. This ultimately results in production of X-ray beams of different energy. Characteristic spectrum is less common mode. It consists of 20 to 30% X-ray beams. It is produced when an electron traveling with kinetic energy equal to or more than that of binding energy of electron in anode atom shell. As we remember from our chemistry classes, each shell had a fixed amount of energy, so whenever an electron jumps from outer shell to inner shell, it will release a fixed amount of energy. Thus the X-ray produced by this spectrum has a fixed energy level. Another point to be noted is that this spectrum is present more in mammographic scans.